Hi everybody. This video is going to walk through our Chapter 1 lab assignment for Net 126, which is actually our Net 125 final exam. So I thought it'd be a good idea for everybody to review based off of the final exam from last semester, because it's kind of like a cumulative review. So before we get into this semester's activities, this is kind of a good starting place for us to recall all that important information, mainly subnetting and our basic commands. So there's going to be two parts to this video. This one's going to go through part 1, setting up the subnetting and everything for our skills-based assessment from last semester, and then the second video will be in Packet Tracer, so showing you all the commands. So this is our final exam. You should have downloaded the student data files for Chapter 1. This is the final exam from last semester, so this is our lab assignment for Chapter 1. And you can print this off if you would like to, or keep it on the computer and type in it. I just wanted to show you to make sure you've got the right file. Now if we flip over to page 3, we kind of see how everything is broken up as well. Remember that everything here is one subnet, okay, and it is labeled the ECU Medical Park subnet. And over here, okay, is labeled the ECU Campus subnet. Okay, let me just zoom in just a little bit there so you can see it. All right, so the left side we've got the ECU Medical Park subnet. Everything in that bubble, remember, can talk to each other. And you've got the ECU Campus subnet on the right. Everything in that bubble can talk to each other. Anything outside of that bubble, remember, is a different subnet, so we cannot include addresses in this one. Okay, they're completely separate than the addresses in this one. They'll have two totally different ranges. Now when we flip to page 3, page 2, okay, our first task is to actually divide this stuff out based off the host requirements. So we've got 3 different subnets that we need to make: ECU Campus subnet, the Medical Park subnet, and then like a future expansion subnet that we won't actually assign any addresses or like devices or anything. We don't have anything for that yet, but it will have like an address and space carved out for us. Okay, our starting address is listed here: 209.165.202.0. Remember, you can just kind of scratch out that starting subnet mask because we really won't need that at the moment. So I'm going to rewrite this stuff for you guys so you can see it here, and we'll come back to this in a second. So we first got the ECU Campus subnet. It needs 50 hosts. The ECU Medical Park subnet needs 120 hosts. Then lastly, the future subnet needs 40 hosts. Okay, now with this information, we cannot go just like it is right now. We need to reorder it, remember, from greatest host needed to least amount of hosts needed. Okay, so the first thing we need to do is reorder this. So first, we're actually going to do the ECU Medical Park because it has 120 hosts. Then we're going to go to the ECU Campus one because it has 50, and then lastly the future one, which needs 40. Okay, so it needs to be in order from greatest down to least. Okay, so you have to reorder those no matter what is listed, no matter how your diagram is arranged. You need to make sure you reorder them first. Okay, that's a big part of it. So let's start first with our ECU Medical Park subnet. And we need 120 hosts available. Now, you may recall this one formula that we used a lot last semester, which was 2 to the n minus 2. Okay, So we're going to use that formula to figure out how many placeholders or bits are we going to borrow. So we need to be, this formula needs to be just greater than 120 or right on 120. It just cannot be below 120. So if we do our formula here, all right, just basically due to whatever exponent you can plug in there. You can start low and kind of work your way through it. You don't have to memorize these. It would just kind of be like plugging in different stuff. All right, so if we borrowed 6, that would only give us 2 to the 6th power would be 64 minus 2 is only 62. So it looks like we got to go up to 7, which 2 to the 7, if we plug in for n there, minus 2 equals 128 minus 2, which is 126. Okay, so that's just greater than that. That is okay. Okay, if it would have been less than 120, then we could not use it. And we don't want to be way greater than either, so we wouldn't want to go to 2 to the 8. That is not acceptable either. We need to do 2 to the 7, just greater than. Okay, so this 7 right here, we are going to use when we bring down our starting address. So our starting address they gave to us, which was 209, and this was in the directions, 165.202.0. Again, I didn't just pull that out of thin air. That was in our directions. They kind of gave it to us. They have to give us that. Okay, so we're going to take this address and we're going to borrow 7 bits. Remember, each one of these octets has placeholders or bits. So this one has 1, 2, 3, 4, 5, 6, 7, 8. Each one of these octets has 8 for a total of 32 placeholders at 32 bits. So we're only going to work in this last one because we only borrowed 7. So with it being a 7 here, and I drew my circle a little too big for the 7 there. All right, you start from the far right. So if I'm borrowing 7, I won't actually get out of that octet. Now each one of these has a value as well. Remember, 128, 64, 32, 16, 8, 4, 2, and 1. So when I borrowed this, I'm going to start counting from over here. I borrowed 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to draw a line to the left of that. Okay, I'm going to look directly to the right of it, and I should have all 7 of the bits I borrowed. But the number that is most important is what is right to the left of this line, or directly to the left of this line, which is 128. That is how many I am incrementing by. So if this is my start, my ending address is going to be 209.165.202. Okay, and I'm in this last octet, so that's where I'm changing. Okay, if I'm incrementing by 128, this is my start. My ending is actually going to be 127. Now, most people would think that that's going to be 128, but it's not. Because if you think about it, if you include that 0, that is 128 addresses from 0 to 127. Okay. You can also think about it like the start of your next subnet, which is going to be for the ECU Campus one, will be .128. But you have to make sure you end at .127 here, otherwise you'll end up with overlapping addresses. So again, there's 128 addresses, and if you don't believe me, you can count them out on your fingers. All right, there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way 127. If you count those out, you'll end up with 128 addresses. The last bit of information to find out is the subnet mask. Okay, the subnet mask. All right, we are in the last octet, so you put all 255s right here, and in the last octet you just look for and add all the numbers to the left of this line. We've only got one, so it's just .128. So if we come back over here to fill in our information based off of that, all right, for the ECU medical part, we got to make sure we come here. Okay, don't fill out the wrong one. Okay, so the subnet range here is our starting and ending. So it would be 209.165.202.0 to 209.165.200.127. Okay, our network address is just the first one, so it would be .0. The broadcast address, remember, is the last one. Oh, I'm sorry, that should have been .202, not .200. Okay. Oh, I'm sorry. All right, so 209.165.202.0 to .127. .0 is the network address, and .127 is the broadcast address. Our first usable host is actually, this means the first one that you can assign to a device is .1. The last usable host is 126, one before that one. And our subnet mask we figured out. Okay, and then the number of usable hosts for subnet B was 126. That's just the the result of our formula. Okay. Also, if we look at our subnet mask in slash notation, this is just basically another way of representing it. So you know when we saw that slash 24, that means 255.255.255.0. Well, how do they figure that out? We had talked about last semester that there are 32 zeros here, and each one has a, is basically numbered, so, or placeholders, bits, 32, 31, 30, and it corresponds to each one here, 29, 28, 27, 26, 25. So this one right here, where we incrementing, okay, that 25 here is basically, it can be represented as 255.255.255.128 or slash 25. So if you saw slash 25, you should be able to draw out some octet here and figure out what this is. You should be able to convert from this to that. So if it was a slash 26 here, then that would be .192, because your line would be here. You'd add 64 and 128 together. So, all right. So we got one of our subnets filled out there. Okay, very important when we go assigning addresses. So now let's work on the second one, which is the ECU Campus subnet. And that one needs 50 hosts. So we got this one done. So now we're going to work on the ECU Campus. Start with our formula, 2 to the n minus 2. So what do we need to substitute for n? Well, 2 to the 6 is 64 minus 2. So 2 to the 6 minus 2. Okay, it's 64 minus 2 equals 62. All right, that's good. If we did 2 to the 5, that would only been 32, so that's not enough. Okay, so we're good with the 6 there. Okay, so our start here will be one after we left off. Our last address in the previous one was 209. Last and previous was 209.165.202.127. Okay, that was our old one, the end of the last one. So here we're just going to start one after that. 209.165.202.128. So that's why it's important that you get all your, or you start out right, because if you get the first one wrong or any of them wrong, all the ones after that will be wrong too, because you'll start with the wrong address. So we're going to draw out our placeholders again. and their values. Okay, and we borrowed 6, so 1, 2, 3, 4, 5, 6. Draw a line to the left of that. We're incrementing by the number right to the left, the number directly to the left of that line, which is 64. Okay, so our ending 209.165, and remember the only number we got to change because we're incrementing this last octet here is that one. So if we add 63 addresses to that, that's how I think about it. I add one less than whatever this is to get my ending. All right, so that just works out mathematically every single time. So our last address will be .191, and the start of our next one will be 192. If you add that outright, the start of your next one will be .192. Okay, so that's my end. My subnet mask for every address in this subnet here is 255.255.255, and again we're in the 4th octet, so that's the only one we need to worry about changing here. And if we add together 128 and 64 is 192. Or in slash notation, okay, slash 26. Okay, because that 64 value there is the 26 placeholder or bit. So based off of that, we're going to fill in our chart. Okay. All right, so we're going to fill in the top half of our chart here for the ECU Campus subnet. Yeah, because we're getting that one done. So our range will be 209.165.202.128 to 209.165.202.191. So my network address is going to be .128 here, this one. My broadcast address is going to be .191, which is that one. Of course, remember the previous stuff up to that, the 209.165.202. Okay, my first usable address here is going to be .129. My last usable address in this particular subnet is .190, and my subnet mask is 255.255.255.192, and number of usable addresses was 62. Okay, so remember I just omitted the 209.165.202.128 for the sake of speed and room, but you do need to put that in there when you are assigning addresses or using any of those. Okay, and also remember, network address and broadcast address cannot be assigned to a physical device. Okay, so that's why we put first usable and last usable, because they're different. You know, the network and broadcast, that's why we -2 in our formula, because you can't use them, can't assign them to a device. So lastly, we're going to do our future subnet, and that one needs 40. Okay, so our formula, 2 to the n -2. We're going to use the exact same borrowing because of the number we need here. 2 to the 5 is only 32, so we need to still do 2 to the 6 -2, which equals 62. So we're still borrowing 6 here. So our starting address again is going to be 1 after where our ending was. So our ending previously was 191. So we're going to go to 209.165.202.192. Okay. Remember, the only time you need to come out of this last 4th octet is if you borrow 8 or more. Okay. So here, same thing as before. We borrowed 6, so our line is going to be here. Okay. So we're incrementing by 64, so our end is going to be 209.165.202. If you add again, it could be 255. Okay, so again, if you include that first number, remember you can't just outright add 64 to this. You could either add one less than that because you got to include this one, just like our first one, 0 to 127 is 128 addresses. Same thing, 192 to 255 is 64 addresses. And you can do it out on your fingers if you don't believe me. Okay, our subnet mask .255, we subnet it in the last octet, so it's all 255 before that, and then in the fourth one we add 64 and 128, so it's 192, just like before, or/26. The subnet mask can be the same across different ones, because remember the subnet mask just really tells you how many addresses is in that subnet. It doesn't actually like reserve addresses or anything. Okay, so let's fill that out, that last one, which is on the next page of our exam. It says future expansion subnet. So our starting and ending and everything will be a little different here. So 209.165.202.192 to 209.165.202.255. Remember, 255 is the last possible address before you got to go over to the next octet. So the next address after this would be just 203.0. All right, you can't have a .256. So the first address here, the first usable was 1.192.255. The first usable, sorry, that was the network address. The first usable is .193. The last usable is .254. Our subnet mask is 255.255.192, and 62 is the number of usable hosts. Now let's write down, while we're here, what we're going to assign to it based off these directions. It says PCs will use the first usable host in their respective subnet. So PCs are going to use the first host in their respectable subnet. The router interface will use the last usable host in their respective subnet. Interface VLAN 1 on each switch will use the second to last usable host in their respective subnet. Consult the diagram. So again, when we look at our diagram, which was on the very first page here, okay, we got to make sure that we keep everything in the right subnet. So the doctor PC, see if I can kind of split it here. Yeah, there we go. So the doctor PC here is in the ECU Medical Park. So when we go pull from that, we need to go to the ECU Medical Park subnet. So the doctor PC is in the ECU Medical Park. When we look here, the ECU Medical Park is right here. So our first usable address is 209.165.202.1. Okay, subnet mask is .128. Okay, the ECU Medical Park switch, which is also over there, okay, for the VLAN, we want to use the second to last usable host. So our ending for the ECU Medical Park was .127. Okay, our last usable was .126. So it wants to use our second to last usable, which will be .125. Subnet mask the same. Everything in one subnet has to have the same interface.
Is right here for that side of the network. So everything, if it wants to get outside of this network, it has to go through that one router interface. Okay, so that's very important. This is the default gateway for that side of the router for the ECU Medical Park subnet. So whatever we assign here is going to be the default gateway for every device in this bubble. So the router 1 G01 there is going to use the last usable host. The last usable host, remember, was .127. Okay, so that's what we're going to assign here. So 209.165.202.127. Oh, I'm sorry, .126. Whoa, that would have been major wrong. Remember, .127 cannot be used because that is the broadcast address. Okay, now since that 126 right here, okay, that's the default, that's the router interface, we're going to use that for the default gateway. Okay. Now we're going to fill in the student PC, which is on the other side over here, so it's going to be a little bit harder to split it. But remember, this is the default gateway for all addresses in this bubble. It has to come through that side of the router to get to the other side of the router. So it has to know how to get out of its bubble, essentially. Alright, so the same kind of thing, the student PC is going to use the first usable address in the ECU Campus subnet. So the first usable is .129. So 209.165.202.129. The subnet mask for this is 255.255.255.192. Okay, the ECU Campus VLAN is going to use the second to last usable. The last usable here was .190, so it's going to be .189. And then here it uses the last usable host, which was .190. Remember, the broadcast address was .191, but we can't use that one. Okay, and then again, this address right here is the default gateway for both of these devices because they're in the same subnet. Alright, so we've got all of our addressing assigned out, even for a future expansion subnet at this point. So I'm going to just kind of show it back to the camera just in case you need it. We got that one done. If you want to pause it at this point, because this one's pretty much over, you can kind of see the exact numbers here. Zoom in just a little bit for you. Okay. And then same thing for the next sheet. Got our future expansion subnet up there. And our, most importantly, our addressing at the bottom that we're about to do. So this concludes part 1. Part 2 is going to switch over to using packet tracer, so make sure you watch that video for the actual commands and assigning these devices addressing. Thank you for watching this subnetting video.